Hi, welcome once again to Math as a Second Language, where today we'll be discussing how we multiply two fractions. And I have to tell you, this was one of the banes of my existence in elementary school because I was bothered by the language. And let me show you what I mean by that. I saw an expression like 1/2 times 1/2. And the teacher said, you don't read this as 1/2 times 1/2, you read it as 1/2 of 1/2. And my feeling was, if you're going to read it as 1/2 of 1/2, why call it multiplication? It just seemed to really confuse me. Not only that, but if I did the problem correctly, 1/2 of 1/2 is only 1/4. See, 1/2 is 2/4, so half of that is 1/4. So how could that be multiplication if it made the answer smaller? Things like that really bothered me. And I think that's partly the reason that I try to be so meticulous in terms of having people understand what's really happening. Let's see what happens if we look at this as 1/2 of 1/2. What happens is, let's suppose we call this 1 unit. So we divide that unit in half this way. So now what we have is this much. That's the half I'm taking. And now what am I going to do? I'm going to take half of this. And what that shows me is I've taken half of 1/2, which is this, but it's also given me an answer to an area problem. Isn't this little square have dimensions 1/2 by 1/2? And so it's going to be what for an area? It's the length is 1/2, the width is 1/2, it's 1/2 by 1/2, so the area is 1/2 times 1/2. That's 1/2, and 1/2 of 1/2 is 1/4, and that justifies once again why we can interchange whether we're talking about 1/2 times 1/2 or 1/2 of 1/2. And notice also why it's permissible that 1/2 times 1/2 can be less than 1. If we look at the big square over here and call this 1 unit, then this square here has what is an area? 1/4 of the entire square. It's 1/4 of a square unit. So there's nothing unnatural about the product of two numbers being smaller than either of the two numbers. Just thought I would mention that sort of in passing. And so once we know that times means of, if we wanted to take 2/5 times 3/8, we can think of it as 2/5 of 3/8. Now we can think again of the cornbread as being 40 pieces, see the 5 times the 8. And notice how we don't draw the cornbread now? So that's 3/8 of 40 pieces, that's 15 pieces. Now here's where reading comprehension comes in. We're not taking 2/5 of the 40 pieces, we're taking what? 2/5 of the 3/8 of the pieces. Okay? 2/5 of the 3/8. Well, that's 15 pieces. We're taking 2/5 of the 15 pieces. 15 divided by 5 is 3. 3 times 2 is 6. So we're taking 6 pieces. And 6 pieces means 6 of what it takes 40 of. So 2/5 of 3/8 of 40 pieces is 6 pieces. So in terms of the cornbread, 2/5 of 3/8 of the cornbread is 6/40 of the cornbread. See, if we start with cornbread as the noun, we want the answer to be expressed as a noun. So 6 pieces is the right answer if you were allowed to use the word pieces here, but since we don't put in the nouns, we're mentally thinking that we're talking about the cornbread. If the 2/5 of 3/8 is modifying cornbread, the 6/40 also has to modify the cornbread. And again, students have often said to me, there's a much easier way to do this problem. All you got to do is multiply across. Multiply the two top numbers, that will give you the same 6 you got. Multiply the two bottom numbers, that will give me the same 40 you got. Why do I have to worry about doing it this long, crazy way that you're using? And the answer is, don't confuse a rote method with logic. Because if you really believe that it's natural to multiply across, then why shouldn't you believe it's natural to add across? Why not say 2/5 plus 3/8 is 5/13? In fact, 2/5 plus 3/8 is much more than 5/13. What is 5/13 based on our last lecture, our previous lecture? 5/13 is a number that's bigger than 3/8 but smaller than 2/5. How can that be the sum of the two? And the area model still works very nicely if you want to use it. If youngsters can still see area better than talking about arithmetic, in terms of the area model, let's rewrite the fraction in terms of the adjective and the noun. We're multiplying 2/5 by 3/8. Notice that when we multiply quantities, we multiply the adjectives to get the adjective part of the answer. In other words, 2 times 3 will always be 6, but what the 6 modifies depends on what the 2 and the 3 modify. So for example, for 5ths and 8ths, I see the numbers 5 and 8. I'm going to divide my cornbread into 8 equal vertical slices. And because of the 5, I'm going to slice it into 5 equal horizontal slices. So now, what is 2/5 times 3/8 geometrically? Here's my 3/8, and what am I doing? I'm taking 2/5 of it. In other words, I'm not taking this whole thing, I'm only taking 2 parts out of 5. See, I'm taking these 2 parts and leaving 1, 2, 3 parts alone. So this would really be 2/5, okay? And what should the answer be? How many pieces are here? 1, 2, 3, 4, 5, 6. How did I get that? Well, from the 2 and the 3 here. How many pieces were there altogether? Well, if I divided it into 5 strips this way and 8 this way, there are 40 pieces altogether. You can pick a smaller number so the kids can actually count them. So what have I taken altogether? I've taken 6 pieces. What's each piece? It's one of what it takes 40 of to make the whole cornbread. So again, this is just a nice visualization. For students who are having trouble but like to draw, I would start with this and then gradually try to wean them away from what's going on. Okay? Get them to do it the way that they're expected to be able to do it. We're not denigrating the usual algorithms. All we're saying is we want the students in their minds to be able to internalize what's happening so that they can use it to solve word problems, which ultimately is the most important things. As I may have mentioned in an earlier lecture, in the textbook of life, there are only word problems. So when a student says, I can do everything except the word problems, it's an admission that he memorized the algorithms and doesn't understand how to use them. Now, there is something very interesting that happens when you're allowed to multiply across. Look, 123 over 369 times 125 over 250 doesn't look like 123 over 250 times 125 over 369. But what happens when you multiply across? This way you get 123 times 125 over 250 times 369. This way you also get 123 times 125 over 360 times 250. Oh, the order's been changed, but that's okay because multiplication is commutative. Now, what was the effect of doing this? Well, I haven't changed the problem, but if I'm lucky, I notice that 369 is the third multiple of 123. In other words, 123 goes into 369 3 times. So another name for this fraction would be 1/3. 125 times 2 is 250. So another name for this fraction would be 1/2. And so the answer is 1/6. Much less tedious, much less cumbersome than if I had multiplied this out the usual way and wound up with 15,375 over 92,250. This does not look like this, but a quick check shows that if you multiply 15,375 by 6, you do get 90,250. Now, the reason I bring this up is that this leads to the mechanical step of students canceling common factors. Students will be taught sometimes to say, look, instead of multiplying this whole thing out, make the observation that 123 goes into 369 3 times. and make the observation that 125 goes into 250 twice, and now the answer is 1/6 right away. Students don't understand that. They'll do it. But the beauty, all this really did was to say, look, instead of going through the trouble of rewriting this, notice that to cancel a common factor, you can cancel any numerator provided there's a similar factor in any denominator. They don't have to be lined up like this because the answer is going to be the same no matter which way you do it. Now, the reason I don't like to teach students to do this is, okay, in this particular problem, they can cancel the 2's and they get 1/7. But if they believe this is natural, what might they do next? There's a 2 here, a 2 here, I'll cancel them, and I'll just call the answer 1/7. Can you see that this answer is not only wrong, but it indicates that the student has no feeling about what a fraction means? Think in terms of the cornbread. If somebody has already given me 2/7 of the cornbread, I already have 2/7. Now somebody gives me more of the cornbread. How can I have only 1/7 left? And don't let the students say things, well, you ate a lot while you were waiting for the other half. No, in math, we don't put in assumptions that aren't stated. If the problem says you're eating the cornbread at a constant rate, et cetera, that makes sense. But everything you do in math has to be based solely on the given information. And so if you have 2/7 of the cornbread, somebody gives you a half of the cornbread, you might not know what the right answer is, but you got to know that it's more than 1/7. Of course, if you do know, you recognize you can only add if you have a common denomination. So 7 times 2 is 14. So 2 out of every 7 is 4 out of every 14. 2 goes into 14 7 times. So the correct answer would be 11/14. What I'm saying, it's nice that you can do this, but what I'm saying is that even without knowing how to add fractions, you should be able to tell that after you've added something to an amount, and that amount hasn't decreased, how can it now become less? So let me just summarize the difference between addition and multiplication so that you see them in your own mind. When you're adding two fractions, it's two fractional parts of the same unit. It could be half of the cornbread plus a third of the cornbread. When you're multiplying, you're taking a fractional part of a fractional part. In other words, you're taking 1/2 of 1/3 of the same cornbread. You're not taking a half of the cornbread, you're taking a half of the third. Now, how does this come up in a word problem? Well, there's all kinds you can make up. Let's suppose the regular price of a camera is $120, but that you only have to pay 3/4 of the regular price when you buy it because it's on sale. Later, you get tired of it, so you sell it to your friend for 3/5 of the price you paid. And the question is, what fractional part of the regular price, not did you pay, because we already know that, did your friend pay? I wrote too fast and proofread too slowly. Okay? Notice again the reading comprehension. The 3/4 is modifying the regular price. The 3/5 is modifying the sale price. So how would you solve this problem? Well, you say, I'm paying 3/4 of the regular price. So I'm paying 3/4 of the 120. 4 goes into 120 30 times. 30 times 3 is 90. So I'm paying $90. What is my friend paying? Not 3/5 of the 120, but 3/5 of the 90. 5 goes into 90 18 times. 18 times 3 is 54. So your friend paid $54. And the question says, what part of the regular price? The regular price was $120. So the fractional part he paid was 50/120ths. And if you want to make that number look a little bit better, 54 is 6 times 9. And 120 is 6 times 20. And so your friend paid 9/20ths of the regular price. In other words, he paid less than half. For every $20 of the regular price, your friend only paid $9. Now, of course, somebody might say, but what if it wasn't the camera? What if you didn't know the price of the camera? Suppose I told you that the camera was on sale, that I paid 3/4 of the regular price for it, and that later I sold it to my friend for 3/5 of the price that I paid. How would I solve the problem then if I don't know the 120? Well, that's exactly where the Cornbread model comes in. Since you're dealing with 3/4 and 3/5, the common denominators here are 4 and 5, you divide the cornbread into 20 pieces, and those 20 pieces would represent the regular price of the camera. So 3/4 of the regular price is 3/4 of 20 pieces. 20 divided by 4 is 5. 5 times 3 is 15. So now you're paying what? Not 3/5 of the regular price, 3/5 of 3/4 of the 20 pieces. You're paying for 3/5 of the 15 pieces. 15 divided by 5 is 3. 3 times 3 is 9. You're paying for 9 pieces. How many pieces were there altogether? 20. So no matter what the original price was, this is kind of neat. No matter what the original price was, your friend is paying what? $9 for every 20 of what the original price was. That's the beauty of beauty of the Cornbread model. You don't have to know what the regular price was to do problems of this particular type. And I think that brings us to our practice problem for today. And for the practice problem, to help you recognize the importance of reading comprehension, I'm going to do what looks almost like the problem I gave you for the practice problem last time. Again, it's Alice, Betty, and Carol decided to share trip expenses in the following way. Alice paid 3/7 of the expenses. Betty paid 2/5 of the remaining expenses. Carol paid the rest of the expenses. What fractional part of the expenses did Carol pay? If you like, and it's convenient, compare this problem with the one I gave you last time and see if you can see the subtle difference. They're very, very much the same as far as looks are concerned, but the answers are quite different. So what I'd like you to do is to pause the video, do this problem, then come back and watch how I did the problem, okay? Since the cornbread concept is relatively new, let me go through the solution in terms of the cornbread. Seeing that the denominators are 7 and 5, we'll assume that the cornbread has been pre-sliced into 35 pieces of equal size. So in other words, the fact that Alice pays for 3/7 of the expenses means she's paying for 3/7 of the 35 pieces. 35 divided by 7 is 5. 5 times 3 is 15. So Alice pays for 15 of the 35 pieces. Now in the previous practice problem, Betty paid for 2/5 of the total expenses. This time, she's paying for 2/5 of what's left. And what's left is now what? Alice took care of 15 pieces. There were 35 pieces altogether. So Betty is going to pay for 2/5 of the 20 pieces. And 20 divided by 5 is 4. 4 times 2 is 8. So she pays for 8 pieces. Therefore, together, Alice and Betty have paid for 23 of the 35 pieces, which means that Carol has to pay for the remaining number of pieces, namely 35 pieces minus 23 pieces, which is 12 pieces. So Carol pays for 12/35 of the expenses. And again, what I'm trying to get you to see is that until we can get the students to feel comfortable, my belief is that the word pieces is far less threatening to them than the word 35ths. And again, what I want them to see is not that Alice paid $15 and Betty paid $8 and Carol paid $12, but rather that for every $33 that was spent, Alice was responsible for 15, Betty was responsible for 8, and Carol was responsible for 12. And I think that brings us to the close of today's lesson. I hope you enjoyed seeing how the adjective-noun theme and the cornbread, which is part of the adjective noun theme, tends to make fractions a little more visual to students than it would be otherwise. And so until next time, have fun, work hard, and I'll see you then.